So, okay, since my city is a crowd sensor for the Future Cities project. It was developed at IT with several people, several students. So what's a crowd sensor? So a crowd sensor is basically a platform that can leverage the participation of people. And so it's about using people to collect data, people as sensors. So it's quite generic, but nowadays you have smartphones. Probably everybody in the room has a smartphone. So who does not have a okay, so who does have a smartphone? Can you please raise your hand?
Who has a smartphone?
Who has a smartphone? Yeah, see? So a large amount of sensors. And the smartphones they have a very, there's a message here, sorry. They have a very large amount of embedded sensors inside them. The GPS sensor, accelerometers, gyroscopes, magnetometers, and they also have, they can scan Wi-Fi networks. They can actually also scan the quality of the cellular network coverage. And so all of this is embedded in the smartphone. Additionally, they are able to connect to other devices through Bluetooth. So you can attach external devices to your smartphone and use the smartphone to relay the data or to collect it locally and upload it later. So that's basically what we are using to turn people into sensors. So that this is feasible is supported by the data on smartphone penetration and especially the next generation. 50% of them already nowadays, and they still don't have, they're not buying their own phones, it's their parents, so they're getting used to it, so these numbers will increase. So there will be more and more people with all these sensors on them. So what we did, we developed a sensing application together with a back office to store the data, then to process the data, and a third platform, which is a web-based visualization for the users. So the users who collect the data, they can access their own data on the platform. They can also manage their data, delete it. This is relevant for privacy reasons. So that's the platform. The sensors that we have embedded, besides the ones I mentioned that are in the smartphone, we have added 3 external sensors to this point. One of them is an electrocardiogram, medical-grade electrocardiogram device from BioDevices. It's a company there. They have a stand there. We have also this strap that you see there. It's like it's typically used for jogging. It's much easier to use, but it's not as precise as the electrocardiogram sensor. And we have this small thing, that black box. It's an onboard diagnostics device which you can plug into your car and collect data from the CAN bus directly. So with this, we have collected some data. So what I'm going to show you some maps of the aggregated data collected between December 18th and January 18th. We had this was a first beta collection with end users. We had 10 people collecting. This is about 40 hours of data and 150,000 georeferenced points. So this is the average speed and the roads of the city. You can see, of course, the VCI, which is our city highway. It's very well marked, and the highest speeds when you start going out to the highways to the north. We also calculate the aggregate fuel consumption. So what you can see in this map, in red, you have the points where the most fuel is consumed. So it's the highest average fuel consumption. You can see there's typically in the highway nodes where people have to brake and accelerate, right, on the red parts. And you also have in the downtown, because it's the stop and start of all the semaphores, so the traffic lights, sorry. This is another type of information that we can extract from the aggregate data, which is where do people spend most time. So this is for the 10 users. That red dot is where I live. I'm one of the most, of the biggest users of the application, of course. And up there is FEUP, so the big ball, and on to the left of FEUP, you can see that's a traffic light on the way to the highway, and there's always a big traffic jam there, so people apparently spend lots of time there because they have to go away from FEUP, right? So this is also just another example of what you can extract, and this is an information which is relevant for network, for example, for networking research, and this is the amount of Wi-Fi access points that you sensed in each area. You can see in the center of the town, you have some areas with a lot of Wi-Fi access points. So this is not the quality of the signal, it's the amount of access points simultaneously scanned. And yeah, as you go to the highways, you have less Wi-Fi access points. Why is this relevant? We can use it, for example, to see what opportunities will you have and where you would have the opportunity to use multiple access points at the same time to improve your throughput. Or we can see where we can, how we can do Wi-Fi roaming, which is something we are working very hardly on, and to enable people to roam in Wi-Fi, and so give some kind, not really, it will never be really like cellular, but give some kind of cellular-like connectivity based on Wi-Fi. Okay. So this is, I have shown you what we do with the data. We are now starting to work on the carpooling suggestions by analyzing mobility patterns and comparing them and being able to see you could, in time and space, if you find matches, you could share your car with some other people going to similar places at the same time or at similar times. So we also had a workshop in December about large-scale sensing. And in the end, we asked the participants to give us ideas about what they would like to have as applications of all this sense data. So what would they like to have? One of the things that we got this also as feedback from the people participating in the crowd sensing data gathering. The people are very keen on having information about their own mobility. So comparing their own trips, being able to compare, is it actually faster, more efficient, more cost efficient, is it shorter to go this way or the other way? So with respect to themselves, also their fuel consumption, also an assessment of how much they spend every week. So we have all these kinds of suggestions, which we are trying to implement also to get more people to participate and to collect data, contribute with their data. What we also had, many users in that workshop suggested that they would like to have services that would provide traffic alerts, so congestion, accidents, roads that are blocked. The alternative route suggestions, so they have their usual everyday routes to work, to go to the gym or whatever, but they would like to have eventually suggestions of better ways to get there, because somebody else does a similar trajectory faster or in a cheaper way. Or moving from taking your car to work to taking a bus, because if you can compare your own mobility pattern with the mobility pattern of buses, you might say, well, it will take you only 5 minutes longer and you have a bus that will take you there. So all these things were suggested by users as services related to mobility. Another very popular kind of suggestion was the access to information about the city. And so this is very much in line with what Vitor Matias just said, that people want to have access to maps. Maps about the pollution, about the well-being, about the traffic, about everything. So, so with our testbeds, we hope that we can help improve the amount of information that people have access to. And the last quite popular suggestion was to support citizen participation. So also as a kind of sensing. So that's it. We would be very happy if you would join the project and just go to the webpage and yeah.
Thank you so much, Ana.